Welcome to the BSides Hardware Hacking Village lab number 6. This lab is going to focus on working with NeoPixels on the Arduino Nano. So we're going to build a circuit and then we're going to implement some code on that circuit. So the three types of code that we're going to do, we're going to blink a single LED or a NeoPixel, we're going to blink a strip, and then we're going to color cycle a strip. So here is the circuit that we're going to be working with. So we have our Arduino Nano in the center, and you'll see the NeoPixel off to the right side here is a single through-hole NeoPixel. It's 8 millimeters. That should be in your Hardware Hacking Village kit. We're going to hook up the control pin to that using a 470 ohm resistor. We're going to also hook it up to 5-volt power and ground. And then we have a strip of 3 NeoPixels that we're going to connect to a pin on the Arduino with a 470 ohm resistor for the control wire. And we're also going to connect that to 5-volt and ground. Then between the 5-volt and ground, we're going to put a capacitor. We're going to use a 220 microfarad capacitor, which is less than the 1,000 you would normally use for a large strip, but it's enough for our purposes here with only 4 pixels. Another thing to note is that we're powering these pixels off of the Arduino 5-volt pin, and I wouldn't recommend doing that for more than 5 pixels because they do have quite a bit of power draw at full brightness. Another piece to note in this diagram, there's a little optional piece that you can add a 9-volt battery to the voltage in on the Arduino. I just kind of wired it in there in case that's something you wanted to do using the terminal connector that was included in the kit. But we're not going to walk through that here. So the physical layout, we're going to use the same strip board that we have for all the 5 previous labs, which means the strip board is going to have a bunch of LEDs and other components on it already. So we're just going to add some components to that. So the number of components isn't that great, but there's a lot of pieces of wire that we have to run between them. So we're going to deal with the 2 470 ohm resistors that we just talked about. We're going to have a capacitor, which is 220 microfarads. Then we're going to have our 8 millimeter NeoPixel, and then our strip of 3 NeoPixels. We're going to wire them in according to the strip board connections that are detailed here. So we're going to step through that right now, and I will show you that. All right. So here I have the strip board the way it was left at the end of Lab 5. And so we're going to work in some of these areas that we haven't touched yet. I have my 2 resistors. I have my capacitor, my 8 millimeter NeoPixel, and then the strip of 3 NeoPixels. And then I have some wires. I'm going to need one long wire. If your kit doesn't have a piece of wire long enough to reach, because we're going to be going from the top of the strip board here all the way down to the bottom area here, you could jump through another area, so do a shorter hop between here and here and here and here, or you can go diagonally across the back of the board if you wanted to. I am trying to keep all my wires and equipment on the front of the board, but you can go directly across the back of the board if that's a necessity for the wire. And so we will start with the resistors. I always like to start with the resistors because they're the easiest to solder on and move around. So let me get my soldering iron ready and we'll get this started. Okay, we'll move all these things out of the way. And as I said, the first resistor that we're going to do is going to be on our strip board between L3 and O3. So if we look at the strip board here, and we have L in row 3 and then O in row 3, we're going to put it right in there. I'll just kind of bend the legs out a little bit. And we'll solder these both at the same time. Then the next one we have is going to go between D5 and H5. Adjust this a little. Now for this one, we're going to work a little bit differently. So let's see, 1, 2, 3, 4, 5. So we have D5 and H5. We want to make sure that we keep the resistor raised up a little bit so that we can access the pins underneath it. Because the next lab, we're actually going to connect something to one of those pins on that strip. So it doesn't have to be a lot, but just kind of stuck up a little bit the way I have it here. That way you can get to the pins underneath to put a wire under there later. All right. And we'll tin up our iron and start these solders. And when you're working on this strip board, because we have a lot of components on the front, you want to make sure you do things like disconnect the trinket if you have that connected, or the Arduino if you have that connected, and make sure you don't apply too much pressure that's going to damage the components on the front of the board as we're pressing down with the iron on the back of the board. It's okay if something bends a little bit, but we really want to be conscious of what is on the front of the board so that we don't damage it. And that takes care of my resistors. And we see that one is up a little bit so I can access the holes underneath. And actually this one ended up a little bit too, which is fine. Doesn't bother us at all. We will cut these pins off, and then we'll go to the next wires. Okay, so the next thing that we're going to put on here, and I try to assemble the components in a way that makes it easy to put them all on the board, so I'm not stepping on myself and having to go over components. So the next things that we want to deal with are some wires. So the first wire that we're going to want to do is going to go between D6 and E16. Let's see, D6, or E12, I'm sorry, E12. So basically what this is going to do, if we look at where E12 is with the Arduino there, that's going to be our 5-volt power out. And D6 is where we're going to plug in one of the NeoPixels. So we'll take a piece of wire here. Let me see which one of these will work. It looks like this one's going to be perfect. So we will just strip an end. And we'll bend it down. We'll strip the other end and bend that down. I'm trying to be careful when I'm stripping these wires not to score the wire itself. That could cause it to break off. We don't want that. Okay, so we know we got E12. So if we come down here, this is Row 12 is there. And E is there. And then we're going to bring that to D6. All right. There we go. I'm going to use my pliers just to kind of nudge it into position and down in there. And then we have two nice wires here that I'm going to bend a little bit so that they don't pop out later. Okay, before I solder those, I'm going to do my next set of wires as well. And this one is also a power wire that's going to go from F12 down to G22. And so F12 is right next to that one, and we're going to bring him down here. So let's strip this end. We'll bend him down a little. And let's take a look if we put him in place. And we want him to go to G22. So 22 is right here. And the G line is back here. So yeah, we have plenty of room there. So I'm actually going to trim a little bit of this wire down. And then right on the 22 mark, I'm going to use that to strip him. Just confirm. Oh, I went one over too far. So that's G, and we're on 22. Okay. And we're jumping over a resistor here. That's perfectly fine. That's not going to affect us at all. And so we'll bend these wires out a little bit to make sure they don't fall out while we're soldering them. And we'll go ahead and solder these connections. So this is providing the 5 volts of power that's going from the Arduino 5 volt power output over to each of the Neopixels. That's why there's 2 wires there. One going up to the 8mm and the other going down to the strip. Left. All right. And so we have our power wires in place. I'll just take a double check. Everything looks good. Yep. And so we're going to trim those wires down so that they're not sticking up the way they are. And then we'll do the next group of wires. Now I chose to use red for power or for red for positive voltage and black for common or ground. But you can use whatever colors you want for these wires. The color is really just whatever you can use to identify it. So if it makes more sense to you to not get confused with the stuff already on the board, then feel free to use different colors for these wires to make it easier. All right, so that got us our power. Now we're going to do our ground wires. So the first ground wire is going to go from A7 across to the common rail, VCC7. And you'll notice that when we worked with the Arduino previously, we didn't bring any of the ground over to that common rail. But we're going to do that on this lab because there's just not enough pins on the strip board to wire this directly into the ground pin on the Arduino. So we're going to wire that ground pin over to the rail, and then we'll wire everything else up. So we'll start with the A7 connector, and that's going to be a really small one because that's just going. So if we look at where A7 is, that's like right here. Yeah, 7 line. That's going to just jump across to there. It's hard to see with these wires, the numbers. Yep. There we go. So 7 is right there, the next one down from our power. So let's get that trimmed. And then we'll bend them down. I'm going to kind of make an arch out of this since it's jumping over other wires. So we'll kind of push these wires in so that they're out of our way. And then I'm going to jump it from A7 over to the VCC rail on 7. It's the common rail. And we'll just jump it like that over those existing wires with a loop. And I'll bend these outward a little bit so that it stays in place until we solder it. And let's get the next wire in before we start soldering. All right, so our next wire is also a ground wire, and this is the one that's actually going to connect up my ground pin. So if you see my ground pin here, it's on this 14 row. And right now we have 2 connections into it, which the 2 connections are on E and F. So we're going to have to connect into G. So we're going to go from G14 across to this VCC rail 14. And we're going to hop over a number of other wires to do that. So even though this is long, I'm going to probably need most of it to hop over all these other wires, but let's measure out. All right, so if I connect it right there, then yep, I'm going to need most of that because I'm going to bend this out a little. So it goes up and over. Like so. And that was a little too much, so we're going to have to try again because I know I need that length of wire. Let me grab another piece of wire. And that's what happens when you score it. If you cut too close when you're stripping, you will score it and the end will just break right off, which is not what we want. Okay. That one's a little too long. There we go. And we'll just twist those ends a little bit so that it stays in place. And that takes care of two of our ground wires, so we need one more for the strip that we're going to be putting here. So this ground wire is going to go between, let's see, G24 and the VCC rail. So G is right here and 24 is right here. So it's going to go from this section right here, and I'm bringing it down to G27 just to get it out of the way of where this strip is going to go. Because everything on that rail is connected, so it doesn't matter if I put it straight across or not, and putting it straight across is going to get it in our way. So let's measure out. If we put this guy right here, and then I want to go to 27, which is about right there. So I'm going to have about that much wire going into the board. I need to cut off this much more. That's excess. And then right where the hole is, I'm going to trim my wire right there. And we'll bend him down. And now we have this one ready to place. There we go. Make sure we bend them out so that it doesn't move on us until we solder it. And then we're going to solder up all three of these wires. wire that doesn't want to cooperate. There we go. And just a couple more. Last one, and then we'll move on to the next one for the control wires. But these ground wires, we want to make sure we get them in place because these will help power our NeoPixels. Alright, so that takes care of the ground wires. Let's trim off those ends, and we'll move on to the control wire. All right, so our last control wire that we are going to want to deal with is going to go from the very top here where we put this resistor in P3, and then we're going to run it down all the way down here to G23, where the strip is going to go. And so we're going to want to wire this like kind of through the middle here the way we did this other wire. So let's go ahead and get that going. We're just trying to get it out of the way of everything else. Trim it down a little. And we're going to put it right down in between that power and ground wire. So it goes right there to right there. And let me bend these up out of the way a little bit. That way they're not going to get loose on me. And then we'll solder them in. Obviously, as you're dealing with these wires being very close to each other, you want to make sure that you're not getting so much solder on there that you're causing a bridge of the connections, because the power and the ground and the control wire, we don't want them connected up. That would be bad. Okay, so let us trim these guys. All right. So now we are going to deal with some of the other components on the board. All right, so we have our capacitor is next. So the capacitor is a polarized device, meaning it has one leg longer than the other to identify which one is supposed to be positive, which one's supposed to be negative, like an anode and a cathode. And we want to make sure that we wire this in the proper way. So this stripe that's on one side with the zeros listed, that is our negative leg. That is our cathode. And then the longer leg that doesn't have a stripe corresponding with it, that is the positive leg, or the anode. And so the way we're going to hook this into this circuit is, if you see our ground for the Arduino, the ground pin, the negative pin, is on row 14. And our positive pin is in row 12. So we should be able to just plug it in between 12 and 14. And we're going to do that on row H, which is right next to the female header pins. So we're going to put the long leg into H12 and the short leg into H14. Now we don't want to push it all the way down. We want to leave room enough that we can bend it over out of the way if we need to run wires behind it. But we don't want it sticking up so far that we're breaking it off if we push down on it. So I'm going to estimate right about there. Looks right. And you can see about how high I made it. And we're going to solder that in place right now. That one could use a little more. There we go. And so that's soldered in place nicely, and we're going to cut the extras off the legs. All right, and so the next thing we're going to deal with is the 8mm NeoPixel. All right, our 8mm NeoPixel has 4 pins on it. It has one pin that's longer than all of the others, and that pin is our ground pin. And so using that as a reference, we know then that the first pin on this side is going to be our data in pin. That's where we're going to receive signals. The next pin, the one next to the ground, is our voltage in. The ground is the longest pin, and then the last pin is our data out. Now we're not too worried about data out on this because we're not wiring it up to go out, but we are still going to solder it in place. That way it helps us hold this thing steady. You'll notice that there's a flat side that corresponds with the data out and the ground, and so we can use that for reference as well. Now the way we're going to hook these into the board is we're going to put our data in circuit is going to go to C5. The voltage in is going to go to C6. The ground, we're going to stretch this pin out just a little bit like that so it can go into B5, not C row, but B row. And then the data out will go into C8. So it's going to be 5, 6, 7, and 8. Most of them are on the C row except the ground, which we're pushing out to the B row. And so if we look at that, the C row is right here, this third row in. The B row is on that side. And so we're going to wire them with those 4 pins in those positions, which is always easier said than done. There we go. And so we'll push that down a little bit. It doesn't need to go all the way down, but we want it down far enough that we have quite a bit to work with on this side. And then we're going to take our pliers and just kind of bend the connection so that it stays in place. We don't want it bouncing out before we solder it in place. Okay, and so there's that, and let's solder that into place. Okay, let's trim those ends off, and we'll move on to the next component, which will be the LED strip, which is going to be interesting how I'm going to have you do this. Okay. So the LED strip, you'll notice, has on one side, there's 5-volt data in, ground, and on the other side, it's ground data out 5-volt. You want to make sure that you're dealing with the side that says 5-volt data in and ground, because we want the data in pin. Now, one thing you may have noticed, or maybe not, is that the pins that are on this strip are exactly 2.54 millimeters apart, meaning they line up with the holes on our strip board. And we're going to use that. Now, another thing you might notice is that when you peel back the sticky back, the copper contacts are on both sides of the board. So we want to make sure we don't take all of this off. We're just going to take off enough to expose the copper contacts on the bottom here. But we don't want to expose the rest of the copper contacts because they might short out on the board. So we're going to leave it like that. And our plan is to put it right here on the E line. So it's going to go onto E22, E23, E24. Now before we connect that up, we want to take those holes, those E holes, I said it was 22, 23, and 24, and we're going to put a little solder down on those pads. Doesn't have to be a lot, just enough that we can melt it onto the bottom of the strip board connectors. So you can see what I did there. In fact, there's a little much on that one. Let me melt some of it away. Okay, and so what we have is those 3 holes have solder on them. Now we're going to lay this on top of those pieces of solder to where that copper is going to be there, but we still want to expose part of the hole. So you're going to be laying it to where the cut line on the strip is about halfway across each of those holes. And then we're going to heat up, because we need to get the iron to touch the solder underneath. And then I'm going to use just a piece of wire to push down on this. So as I heat it up, I'm going to push down and make sure that it makes connection. with each of those on the bottom. Now, to be doubly sure we have a good connection, I am also going to hit the solder iron on each of these pads on the top, and I'm going to heat it up a little bit and put a little solder there. So you're going to want to heat it up enough that the solder sticks to the pad, like so. You're going to want to make sure you take a good visual inspection of this and make sure that you haven't bridged any of those connections. We want all three of those connections to be good and solid, but we also don't want them to touch. So we don't want the 5-volt touching the data in or the data in touching the ground. And so with that done, I got a little extra solder right here I'm going to remove. Okay. So now we have one little piece left, and it's more of a mechanical thing to hold the strip into place. So what we want to do is put a piece of wire between the holes here on the VCC that are on either side of the strip board. This way we can solder this in place and hold it down, and it's going to prevent any pressure being put onto that strip board. That way onto the strip of NeoPixels. This way the NeoPixels we're not worried about them coming loose on those solder points that we just put on there. So this is not being used electrically by us at all. We're really just using it as a mechanical way to hold it down. And I had estimated that we would go between the VCC 21 and 25, but based on the angle of your strip, you may have to go across to 26, which is what I might do here, or I might be able to get it into 25. Let's take a look. It looks like I got to cut some more off of that. A little too long yet. It looks like it will go into 25. And so we're just going to make sure it pushes down all the way in there, because the whole point of this is to lie flat and hold this thing from coming up. So if we had a big gap there and it can move back and forth, that would defeat the purpose. And we're going to solder this down. And we're not causing any problems with the circuit because this is going between 2 points on a rail that's already connected. So this is already electrically connected. This is not going to cause us any issues. It's just to hold it in place. And so we'll just trim this up, and then we'll be ready to write some code. Okay, so what we want to do now is plug our Arduino into our board, and then we're going to plug it in with our safety USB connector, and then we're going to load some code on it. All right, so when you first plug it in, your Arduino is probably still running the code from one of the previous labs, and it's not doing anything with the NeoPixels. So we're going to change that, but you might notice that the strip of NeoPixels is not lit at all, but the single NeoPixel is lit up with blue. And that is just one of the defaults of that type of NeoPixel, is that with lack of any other signal, it is going to light it blue. That way you can tell that it does have good power, even with lack of signal. So with that lit blue, that'll change once we put our code. So let's do this code that's going to blink that NeoPixel red. So what we're going to do for this code is we're going to include our NeoPixel library. That's the Adafruit_NeoPixel.h library. And earlier in this presentation, outside of the lab, I explained where you could download that using the Arduino IDE. You can use the library manager to get that. Then we're going to define two constants. We're going to get an LED. LED6 is what I'm calling it because that's what the schematic has. We're going to define its pin as A1, and then we're going to tell it the number of pixels, which is 1, because we only have one NeoPixel in this chain. Then we're going to create the NeoPixel object, where we're going to call LED6 our object name, and we're going to tell it that number of pixels and the pin, and that it's an RGB type, and it's running at 800 kilohertz. I know that this is an RGB type just because the documentation of the APA106 NeoPixel tells me that. But if I didn't have that documentation, you could always trial and error, and if anything, it's just going to reverse the colors on you, and then you can change it around. So to that end, to knowing whether it's RGB or not, you might want to blink red and green at different times in your code to be able to tell whether it's working in the proper order. So in our void setup, we're going to do our LED6 begin and then show, and this will prime that NeoPixel LED to be ready to go. And then in this loop, we're going to set the pixel color to red, and we're going to show it, and we're going to wait half a second. Then we're going to set it to green. We're going to show it. We're going to wait half a second, and we're going to set it to blue, show it, and wait half a second. So let's take a look at what this looks like when we do this. And so here's the code loaded in the Arduino IDE. Let me move this out a little bit so we can get a better view of the board. And I'm going to verify this code by clicking the verify button. And you can see it's compiling the sketch, and then when it's done, it tells me how much memory it would use. And then we're going to upload this sketch. And we can see our NeoPixel here is flashing red, green, blue, just like we told it to. And so that's a simple piece of code that explains how the NeoPixels work with a single pixel. So now let's take a look at how to incorporate the strip of NeoPixels. Okay, so this next piece of code for the strip of pixels, we're going to do basically the same thing we did for the single pixel. We're just expanding it out. So we're going to define some constants for LED7 is what I'm calling this strip of pixels. And we're going to define the pin as D10, which on an Arduino we don't have to specify the D. We just put it as pin 10. We tell it that there's 3 pixels there. Then with our object, we tell it that it has D10 with 3 pixels, and it's a green, red, blue type. Now I know this is the green, red, blue type because that's what the documentation for the strip told me it was. And 800 kilohertz is what I typically use for all of them. I know some of the older NeoPixels use the 400 kilohertz. I haven't worked with too many of those, so this is a good bet that it'll do what you need it to do. And you could always switch around red, green, blue, or green, red, blue as needed. But our documentation told us what to use here. We're going to prime it, just like we did with the other pixel. And then we're going to set these colors a little bit differently. So in this case, I want my strip to display red on the first pixel in the strip, green on the second pixel, and blue on the third pixel. And then for the next iteration, we're going to shift that around to where the first one is green, second one is blue, third one is red, and so on. And you can see how I'm addressing these individual pixels as 0, 1, and 2, because those are the 3 pixels in that strip. And so just like before, we're going to execute a show command and a delay to delay it half a second. So let's go ahead and open up that code in the Arduino IDE. Okay, so I've got the new code opened up in the Arduino IDE. And we can double check it, make sure, yep, it has everything we want it to do. So we're going to verify this code. I did scoot over my board here a little bit so that you can see all 3 pixels in that strip. And it's verified complete, so now I'm going to upload this code to the board. And we can see that it took effect on our pixels. So they're doing exactly what we told them to do. And it's very bright. So the one thing about these strips is they tend to be a lot brighter than your traditional LEDs. So you have to sometimes step down the brightness, and we'll look at that in the next piece of code. So let's take a look at that next piece of code now. Okay, so here's the next piece of code, and I guess I was mistaken. We're not going to adjust the brightness here. We do that in the next lab. So in this one, we're going to color cycle the strip of NeoPixels. What we're going to do is going to be the same top-end code that we used before for defining the NeoPixels, but now in our main loop, instead of just setting the colors with static numbers, we're going to randomize a little bit exactly how we're doing the color assignments using some math to give us a nice color shift. So we're going to implement a for loop that's going to run iteration numbers between 0 and 255. I'm going to make another variable equal to that iteration number so that I can adjust that variable. Then if it's below 85, I'm going to be cycling the colors between red and green and doing some math to slowly transition between those two colors. If it's greater than 85 but less than 170, then I'm going to start messing with the color iterations between red and blue. And then over 170, we'll be shifting between green and blue. So between these three, it should give us a nice color shift between red, green, and blue using all the color combinations possible by making some parts of the LED dimmer while others are brighter. And then we set our delay much lower at only 50 milliseconds because we're going to loop through this 255 times. So we want it to be low enough that it's perceivable and doesn't just look like a set color for a while. So let's take a look at that code in the Arduino IDE, and then we'll go ahead and get it applied. Okay, so here we are in the Arduino IDE. We have our code. We can see all the definitions we had before. And we see that we're doing the math on the red, green, and blue positions to set those colors. So let's go ahead and verify this code, and then we'll push it out and see what it looks like on the board. And we'll upload. And there we go. We can see that it is slowly shifting from color combinations. That's giving us a nice effect. So that is the last piece of code for this particular lab. I want to thank you for participating in this lab, and if you're interested in seeing how this similar circuit works using the Trinket and CircuitPython, then please attend the video for lab number 7. Thank you so much, and we'll see you next time.